Hi all, welcome to part 6 module 2 logic system design. So what we were discussing in part 5 is about the important Boolean algebraic theorems as well as postulates, right? Particularly the switching algebraic theorems and postulates. Hope you remember. And we were discussing the proof also. I think part 5 we discussed how this idempotency can be proved. So what was idempotent law? Like any Boolean variable plus another Boolean variable that will give you x, as well as x dot x is also going to give you x, right? I mean, this operation you can repeat any number of times. You can generalize it like this also, like x plus x plus x plus any number of times, same x, that is also going to give you the x. So over the same operand, if I am repeating the operation, I mean operator, if I am repeatedly applying it, it is giving you the same answer. It's not generating something new. That is what is the meaning of idempotency, right? This is what we proved last, right? Now let's see proof of some more important theorem. The next one is, hope you remember what is this law. If I have a x sub expression, say like x plus 1, I can minimize it to 1, right? So what is happening here is, where this x can be of anything, like it can assume 0 or 1, but whether it is 0 or 1, irrespective of that, this 1 is coming as a output, right? This 1 is something that is dominating the entire expression, and that is what we are having as a minimized expression. So this is what we call as the dominance law. Dominance law, because here 1 is dominating the entire expression, right? And similarly it's dual, every expression or equation, Boolean algebraic expression or equation, it will be having a dual also. If the given equation is valid, its dual is also valid. So how can you come up with the dual? This x remains as it is, plus become dot, and 1 becomes 0, and that on next the result 1 also becomes 0. So that is a dual, right? This one. So both are correct, right? And we are going to see the truth. Why it is correct. You can definitely use a truth table, but the truth table, it is very easy. You can see like some variable x on one side, and other operator is 1, and finally we need what is x plus 1. That is what you have to verify, right? X can assume 0 or 1. 1 means always it is 1, right? This is how. It's a constant, right? One of the operand is constant, always 1. X is a variable that can assume Boolean value 0 or 1. Now when you perform OR operation, 0 or 1 is 1, 1 or 1 is also 1. So the result is also found to be 1. So if an expression that is giving 1 always, we call it as tautology. I mean true always, right? Tautology and contradiction. Same concept you can apply here also, but at this point we are focusing on dominance law, that's all. So this is how you can prove it using truth table technique. Now let's see how we can prove it using the mathematical argument. So this is something you have to focus more, because truth table is something very straightforward approach. So in exam, if they are asking state and prove dominance law something, you have to, or state and prove the following law, like x plus 1 equal to 1, like that they can give you. You have to give the proof in this way, okay? That is what is expected by default. So what we can see do is like you start with the LHS and try to reach the RHS, right? So when you are looking at the LHS, you can see x plus 1, just like before we multiplied it with 1, because we know instead of writing it as a postulate 2, give its accurate name, right? Because textbook they are writing like that, but in exam what you will write, what is this postulate 2 be? You don't remember like that. Simply what we done is like some expression, I multiplied it with 1. You can do this multiplication at the right side or left side, because commutative is by default is true for Boolean algebra, right? So or this is one way, or what we can do, 1 dot x. Anyway, both are going to give you x itself, right? So that is identity law. This one is acting as identity element, right? Identity law. So as per this identity law, I can simply multiply it with any expression. I can just multiply with 1, no problem, or any expression I can add with 0. So both are fine, right? So here I am multiplying with 1, and what I am doing, this 1 I am replacing with this 1 I am replacing with x plus x dash. So that also this complement law, right? Complement law says x plus x dash is equal to 1. That is a identity element of dot, something like that, right? Hope you remember. So And here also we are using it in the reverse direction for more simplification. Actually, we feel like now the expression is expanded. Initially it was x plus 1, now it is x plus x dash into x plus 1. How we are getting it? What we done is like this I mean this one we first we multiplied, and then that one we represented like x plus x dash. The same way we done before also. Now you can see that distributive law. So whenever you are having something like this focus, this x is common, right? So take that x outside, and this plus is common, right? And take this plus outside, and what remains is our x dash dot, right, 1. I am using different color for you to understand. So take it outside, that is x dash dot 1. So that's all. And now you know, so this is by distributive law, right? So how we are writing this? By applying distributive law in a reverse way. Okay. Now you know what is x dash dot 1. X dash dot 1 is x dash, that is our identity, right? X dash dot 1 or x dot 1 is x, that is identity. By identity law I am getting this step. And finally x plus x dash, what is it? X plus x dash, that is 1, right? We know by complement law, right? Complement law. So simply you can use this, right? And what they are writing, the dual you can prove in a similar way by just take each step of this particular proof, apply the dual, something like let me just start like initially I started with x plus 1. So here instead I will start with x dot 0, and that x dot 0 how can I write? Because here I multiplied with 1, instead in dual I will add with a 0. So just opposite thing, that is x dot 0 plus 0, something like that. Now this 0 how can I write? That is equal to x dot 0 plus 0. I can write like here 1 I written like x plus x dash. Same way 0 is x into x dash, just the opposite thing. Now I can take this x outside, right? From these two equation I can take x outside and dot outside, and what remains is 0 plus x dash. And you know 0 plus x dash is what? 0 plus x dash is x dash itself. I am getting it as x dot x dash, and x dot x dash is what? 0. So the law is being proved, right? I started from the LHS and I reaches the RHS, right? Same way here. And there is one more law, that is involution law. Hope you remember, like complement law, something like that. So when I take complement of something and its complement, x complement, the whole complement, that is going to give you the original expression back, x, right? So that is also they are giving a small proof. You can go through this. Okay. So from the definition itself they are trying to show that complement of complement is x dash, then complement of x dash will be x itself. So that is what we are writing here, right? So what we are interested is, we know that complement of x is x. Sorry, yeah, I'm sorry I'm going to represent complement of x by x dash. Now let me ask you the question, what is complement of x dash then? Right, the complement of x dash means I will denote it by x dash, its complement, right? What is complement of x dash? That I know. If x dash is a complement of x, then x will be the complement of x dash, right? So that is the way they are proving. Just go through it. Now the last thing, this is again I saw in university exam also. This is something repeated question. Just this law, prove, state and prove this law. Hope you remember what is this law. See what is happening here. This x plus xy, you know, the entire expression is being absorbed by this x, right? When I am having something on LHS like this, some sub-expression like this, simply replace it with x. But see this x and x, it should repeat. That is a requirement. And whatever be this y, that is not going to come in the output. Simply the entire expression, that y, everything is being absorbed by x. So we call it as what? Absorption law, right? Absorption law. Here you can see that the variable x is absorbing the entire expression. So how can we prove it? So here also we are using somewhat similar steps. So what I done is like x plus, so we started with the left hand side, right? Then this first x I simply multiplied with 1. That is now clear to everyone. What is that? X dot 1 is x itself. So wherever I am having x, I can write it with x dot 1, or whenever I am having x dot 1, I can replace it with x. Both are fine. So that is our identity law, right? Identity law. Now again, now we have the possibility of distributive law. We are going to apply distributive law in reverse direction. So what we are doing is something like this. If I have x dot y plus x dot z, what I can do is I can take this x dot outside and y plus z, right? So this is the way I am applying distributive law. So in a similar way, what I can do, so same, see, you can see x is coming here, right? So take that x outside and dot 1 plus y. Now what is this 1 plus y? Tell me. 1 plus, see, till this is clear, right? Now what is 1 plus y? Right now we studied it. X, so it is something like a 1 plus y or y plus 1, whatever it is. Both are, the entire expression is dominated by 1, right? So that is by dominance law. Dominance law. I think I am making it a little bit complex. What I can do, let me write down. You know the distributive law, right? So let me write down the name only. That is enough, because that much detail is not needed. Distributive law. So as for distributive law, I just I can take this x outside. I am applying distributive law in opposite direction. See, now what else? Now this 1 plus y I am just writing as y plus 1. Whether it is 1 plus y or y plus 1, you can directly go to this 1, that is fine. But still what they done is by commutativity, and they gone for one more step, right? Commutativity law. Now because we studied it like y plus 1 is equal to 1, but both are same, like y plus 1 or 1 plus y, both are 1 only, because 1 is going to dominate that or, that's all, the entire expression when or is coming in between this. So this y plus 1 I am replacing with 1 by dominance law. So what is x dot 1? Finally I am getting it like x dot 1, and this x dot 1 is nothing but x by identity law. So I am writing everything in detail. Hope it is very clear to you right now. So the only thing is how to start this kind of a theorem, because they are very fundamental theorem. So it's not as simple as simplifying an expression, but for subsequently we saw simplification. That time any expression, just look for some distributivity, dominance law, absorption law, and apply it properly, and you will get a very reduced form of the equation. But to prove these fundamental aspects, some starting point is needed, that you just remember what is the way people are proving it. You can try in slightly different ways also, you will get it. And truth table is of course going to be the straightforward method. So here it's shown, see, before truth table technique, it's dual, right? The given form is like x plus xy, dual will be x dot x plus y. I mean that plus and dot will change, that is also. So this also you can prove easily by the same steps. But in every sub step you have to apply the what called dual. Okay, let me show you. Like what you have to do is like x plus y. You start with the left hand side, right, and try to reach the right hand side. So what we are going to do, this x here we multiplied by 1, right? But as it is a dual part, what you have to do is you have to add it with a 0. Multiplication will change it to addition. Just apply the dual of the previous steps. Okay, that's all. Here I multiplied with 1, here I added with a 0, right? That is how we are getting the dual. And then this x plus y, right? Now distributivity you can apply. So what you can do is you can take this x plus outside, then 0 dot y, right? 0 dot y, because in between I am having dot, that dot is coming here, right? This dot is coming here. Now tell me what is 0 dot y. X plus 0 dot y is 0 by dominance law again, right? And this is nothing but x by identity law, right? So that is how you are reaching the right hand side, just like this. So that's all. Now you can simply see this result in truth table form. Like you can see that this is x and y for combination x y. You can see like this, and you can observe that x plus xy and x both are same, right? See, Just compare. This is what our law is saying. X plus xy is nothing but x itself. We can see that the truth table of both x and x plus xy both are same, right? So we can conclude x plus xy is equivalent to x itself. Yes, that's all. Now there are other cases, like you can observe that associative law is true. DeMorgans Law is also hold, but just like previous way, it's somewhat difficult to prove this associative as well as DeMorgan. You can try, no problem. So typically we can depend truth table for that. For if the other type of proof is found to be tough, you can go for truth table method. So textbook people are trying with the truth table, but you can try the other way also. You can try it out, right? So you can see that this x plus y the whole complement, x plus y the whole complement is nothing but x complement, this plus become dot, y also become variables become its complement, and operator will change like that. So that is being proved by taking the truth table, and what is this x plus y the whole dash and what is x dash dot y dash. You can see that both are same. So this truth table method, but we can do try in the other way also. Okay. Now one more very small topic we can just go through. What about the operator precedence? In C language and all, we have some precedence for operators, and sometimes it is there in our mind by default. If it is I have an expression like what is see I have an expression like 5 plus 6 into 7. You know that this multiplication will happen first, right? So 6 into 7 plus 5, like that you have to evaluate, and you are not going to do like 5 plus 6 into 7, 5 plus 6 11 into 7. You are not going to do like that, right? Because that precedence order is something default in our mind. So that is something what we are used in our mathematics classes and all. So that is regarding this multiplication division. Always multiplication and of course division, they are having higher precedence than addition and subtraction. The same way, equivalently multiplication, here we have a AND gate, right? And AND gate or AND operation. AND operation is having higher precedence than OR operation. And in any expression in C and all, the unary operator is always getting the highest precedence. Than binary, and not highest. Unary operator is getting higher precedence than binary operator. See, because so that is the precedence rules. That is what the precedence rule says, right? Something like if I that unary operators in C and all, the pre-increment, post-increment, those things. You can take any example. So in Boolean algebra, we have the unary operator, that is this negation A. Negation A or A complement means I am taking the complement. If A is 0, the complement of A will be 1. That complement operation or the not operation. So that is having the higher precedence than and or, because both and or are binary operators, and always this parenthesis will get the highest precedence among all, right? So that also you keep in mind. So this is the precedence order. This is the order. Okay. So parenthesis will get the highest precedence, then not gate or not as an operator, unary operator, then and or, they are binary operators, and is having higher precedence than or. So if I have some expression like x plus y dot z plus some z complement, anything, something like that. So here you have to remember, maybe let me write plus y plus x something, right? So see, so which will be evaluated first? Always a bracket will evaluate first. So y plus x is going to be evaluated first, then this x dash will be evaluated, right? So this is the first thing will be getting evaluated, then this will be evaluated, then this dot will be evaluated, right? Then this plus will be evaluated, and again here this plus itself is repeating 3 times, where that associativity law will be there, precedence and associativity, right? So you can see by default this plus and dot, just like arithmetic operators, they are left associative. It will be evaluated from left to right, but that is something a language dependent concept. Okay. Anyways, for simplification purpose and all, it's enough to know the precedence among these 4 things. Like parenthesis will always have the higher precedence, then not, then and, then or gate. That is enough for the time being. Okay. So keep that in mind during simplification and all. Don't take something different. Okay, so thanks for watching. You can ask your doubts and all during our class based discussion. Yes, bye.